we're going to take a slight detour here and look at this idea of net ionic equations. We're going to come back to this at the end of the chapter, but it sort of makes sense to look at this after we've seen precipitation reactions and acid-base neutralization reactions. It looks kind of simple to take a look at this right now. So I'm on page 5.12, and here's a reaction. This happens. This reaction actually occurs. It's obviously a precipitation reaction. We're going from aqueous to solid. And what we call this sort of old-fashioned reaction where I've got compound, 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 compound. Even though they're aqueous, we know they're broken up in water, but we've written each as a compound. And sometimes it can be a little misleading, but we say, oh, that's a molecular formula. Even though it's an ionic compound that doesn't have molecules, it only has ions. We say, oh, molecular formula, molecular formula, molecular formula, molecular formula. So we might refer to this now as a molecular equation. So we could say all compounds. Now, that's not a very honest description of what's happening. There is no aluminum chloride in the water. There is no sodium carbonate in the water. There's no sodium chloride over here in the water. There is aluminum carbonate sitting there in chunks at the bottom of the reaction vessel. So if we were to be more honest about this and we thought about what's really going on, I really would be more honest to say, oh, I've got aluminum 3 plus and Cl minus. I don't really have aluminum chloride in the water. I've got aluminum ions and chloride ions. It's aqueous, so they're broken up in the water. Well, let's see. At this point, I am going to go ahead and say, well, there's 2 aluminums and 6 chlorides. Now, that doesn't make sense. You might want to stop the video for a second and think, well, how did he get the 6 chlorides? Okay, so I'm going to do the same thing up here with this sodium carbonate. There's no sodium carbonate in the water. There are 6 sodium ions and 3 carbonate ions. Now, this should say aqueous, 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 but I'm lazy. So I usually use a rule that like all ions are aqueous. Now, the homework won't let us get away with that, but I always just say, okay, look, if I write an ion, it's aqueous. I don't have to write aqueous, gas, liquid, solid. It's just going to be aqueous. Now, that's a much more honest description of what's really going on in that solution. And I'm going to do the same to the other side. Here I've got aluminum carbonate, but it's different. It's a solid. So I can't break it up. It's a chunk. It's a solid. See, CO3, 2, solid. That's an actual chunk of solid white crystalline material sitting at the bottom of the beaker, the flask, whatever the reaction's happening in. And then I could say, okay, now I'm going to take this 6 Na plus 6 Cl minus. Now what I've done is I've broken everything up into ions. Instead of saying aluminum chloride, no, there are aluminum ions and chloride ions. There's no sodium carbonate, there are sodium ions and carbonate ions. And so this gets the clever name total ionic equation. It's more honest. We're saying, well, let's not write things as molecules or formulas. When they're dissolved in water, when they're ionic compounds, they're broken up. Now this brings up something interesting. Here's a question for you. Are there any ions from left to right that are unchanged? Essentially, they've not reacted. The answer is yes, emphatically. And if I look up here, I go, well, wait a minute now. I've got 6 chlorides here and 6 chlorides on the product side. They didn't react. Cl minus. I've got 6 sodium ions here, 6 sodium ions there. The sodium ions did not react either. So we could say our lives might be easier if we just said, okay, let's list the ions that are in the solution and in the product, and let's ignore those that didn't do anything. We sometimes say they're spectators. That's what this next part is. It says, okay, well, wait a minute. Some of the reactants and products are completely unchanged, which means they really didn't react. Now, I might then say, well, why don't I do this? If I ignore those, I could say, take that out and that out. They didn't react. I could say, well, wait, I've got the 6 sodium ions and 6 sodium ions. I'm going to ignore those. And when I do that, we call it the net ionic equation, meaning, okay, don't tell me about stuff that didn't react. Just tell me the net reaction, which would look like 2Al3 plus 3 carbonates gives me Al2CO3 solid. Now, aqueous. So we've got molecular equation, our old-fashioned equation. Everything's written as if it's quote-unquote a molecule. Then we said, well, let's look at the total ionic equation. What if we were more honest and we broke up the soluble ionic compounds into their ions, which is really what they are in solution? That gives us the total ionic equation. And finally, the net ionic equation is, well, what if we just ignore these things called spectator ions that were there, but they're the same on the reactant side, same on the product side, so they just didn't react. And that gives us this net ionic equation. And here are the rules at the bottom. If you write it as compounds, there's my molecular equation. Break up soluble ionic compounds. And something we didn't do yet, this also applies to strong acids. And I know you've made your flashcards and you know your strong acids, HCl, HBr, HI, HNO3, H2SO4, HClO3, HClO4. Okay. And then when we cancel or ignore the spectator ions, what we're left with is the net ionic equation. Okay, that's it for this page. We're going to go into now, I'm going to break it up into 2 smaller pieces, but we're going to look at redox reactions. They're complicated and important. So I think we have like 6, 7, 8 pages to go through in the lecture supplement on that. And then we'll come back at the end and say, okay, let's just remind ourselves about these net ionic equations. All right. And as always, if there are any problems with the video, I'm looking at them on YouTube. Everything seems to be going okay, and it will even get better in a few days when I've got a better computer. Things seem to be going okay. If it's too blurry or the files are too big, I can try to tweak it in the meantime. As you can see, it's not pretty, but it's getting the job done. All right, I'll see you at the next video. Bye now.